This conference will now be recorded.
Yeah. First of all, thank you for joining this demo session for the microservices. Today we will briefly, talk about what are we going to cover as part of this course, and different tools and frameworks that we're going to, teach and train, and also help you to code yourself as part of this course. And also, we'll try to give you different aspects of this course where can we use this one, and we would like to excel ourselves or master the microservices with different domains, and then we are going to touch upon those points as well. And we will see different deployment aspects, not only just creating microservices, and also dockerizing them or containerizing them with all these things and all. And also will help you to orchestrate those images through Kubernetes and all. So this is the essential plan that we have planned to roll out a course and train and make people to code themselves, and also develop applications right from the scratch till the deployment. Okay, so let me go ahead. The objectives that we have set for this course are the following: like to make and understand and also master the participants of this course to develop microservice based applications, and cover different aspects of microservices, like we will see as goes by. And we'll try to see the different aspects and the features that we are going to cover. Next is that we will cover both type of microservices. There are two different types of microservices we generally see. The first one is request response based microservices, and the second category is the event driven microservices. In the request response based microservices, mostly test based applications, and how when we create multiple services, one application into multiple microservices, and structurize them to communicate one service with the other with the help of naming server, we call it as service registry, and how they are going to pass the information or exchange the information between the microservices. That's going to be the first part. The second part is the event driven microservices. The domain is going to be different. Mostly the e-commerce service and banking domain applications are mostly using event driven microservices. The reason being that there are a lot of transactions involved, from a, if you take a state machine kind of thing, let's say, for instance, if we take a Flipkart example or Amazon e-commerce example, right from user search of items to inventory of products, and then see if the product is available, user can select that product and move that product to cart for purchasing, and then from cart to he can purchase, and then he can create one purchase order of the item. And then, sorry guys, let me stop this one so that purchase of the item. And after purchasing the item, then we need to track for the delivery. So if you start from searching of an item till the delivery of the item to the end user or a customer, then the entire thing they call it as a life cycle, right from, if in case if the user is anonymous user, sign in also comes into place, right? So the entire life cycle is treated as a state machine. When the state is changing from one particular state to the other state, for example, we are searching a product, and from that state to moving the item that the user is interested in, from such state to the moving the item to the cart state. That means there is a state change happening from one state to other. And again, from moving the item to cart, from there to you can create a purchase order just by paying the amount and all. So the state change is there. Every state change that is happening is going to be covered, and each state change is going to create a transaction. Right? They call it as a transaction. So in the holistic life cycle of user purchasing an item, there will be multiple transactions involved. So each transaction has to be tracked, and then the status of the entire purchase has to be updated every now and then. So there is importance of tracking the events. Each event, each transaction that I was talking about is created as an event, and each event is holding up with some status and some new data. Okay, the data that they are holding at the such state may not be the same data that they are holding the item moving to cart. Right, once the item has been moved to cart, then the state might be different. The data that is going to hold might be different in the event, right? While we are creating the purchase item, things like that. So event-driven microservices mostly would be, applicable in the case of transaction-based systems like e-commerce or banking systems or any other, transaction-based systems we call it as. Whereas the request response based microservices are mostly focused on the applications where data exchange happens, and each and every microservice can be created with single responsibilities. In such scenarios, we generally go with request response based applications. For example, if I have to give, let's say, most of the what do you call CRM applications are request response based. The reason, let's say, for example, a Zoho, right? Most of you are aware of Zoho. Zoho is a employee management system, right? We can track the time of the employee, and we can also see the attendance regularization. We can also see the other aspects like employee on time, off time, employee, worksheet, and employee tasks for the month, and employees salary related aspects, and all those things, right? So when each aspect of the employee is created as a microservice. For example, attendance is one microservice, employee work related tasks is another sheet or another microservice. Thirdly, the employee financial transaction related, let's say salaries and then adjustment of salaries, ITR, and all those things are comes under another category. And employee training related aspects, whatever the skill development programs that employee is going through, right, or employees are going through. So those can be another microservice. And if you see the microservices, most of them are clearly separated. So they are holding up single responsibility, and they are clearly separated from the responsibilities. So the employee attendance may not be interacting or directly related to the employee's work, right? Of course there is a relation, but it's not tightly coupled.
No, I cannot hear anything.
Hello.
Yeah,
Hello.
this hello. Yeah.
Class is going or not? I can't able to hear anything.
Yeah, even in my case also same. I also told the same thing.
But he is changing the slides.
Yeah.
Yeah, I'm sorry. Yes. Give a quick confirmation.
The audio is breaking, so on and off it is coming now.
Yeah, I think it is sustained now. There was a network glitch, and I believe everyone is able to hear me loud and clear
Yeah,
right now.
now I can hear.
Yeah, I'm sorry. So first of all, we'll cover what is the need of microservices when we have traditional monolithic, applications are available. When I say monolithic, mono stands for single, right? And lithic means stone. Single stone applications in literal sense, if you want to take it, or single frame single frame service or single frame applications we can call. For instance, if you take any Java-based applications, whether it is a jar file as an output or a war file as an output, mostly we'll see these aspects would be covered. We will be having a GUI first of all, a presentation layer, and below to that we can have different service layers, business layers you will have, and then followed by database layers, I mean database access layers, and then finally a database, right? I just divided into three different services, and Azure internally they have categorized into business as well as DAO, okay, to interact with the database. And this entire war file is going to be deployed in the application server like Tamcard or a Wildfly or something like that. Okay. Now, what is the disadvantage with this service from your point of view? Most of our applications are like this. What are the disadvantages that we face? I just want to hear from you. No problem, guys. You can openly speak. If there is, if the answer is not quite good, that's still okay. But let's have an interactive session so that you can understand the real sense of having microservice architecture and then designing our applications into microservices. What are the disadvantages that you feel? Let's say if one of the service is failing, let's say in product service or user service or even auto service, let's say one of the service is failing. What are the implications that we are going to face if one of the service is failing? Anybody?
Yeah, basically it is tightly coupled. So if any of the services failed, then we have to rebuild and redeploy the entire application.
Wonderful answer. The first and the core he has hit. You are right on the money. Okay. Let's say if one of the service went down, then immediately we have to call someone first of all, and then we have to tell them that please there is a problem. First of all, we will be operations team would come to know that service is failing, and then they will immediately call or trigger a mail to development team. Then development team has to take it up. what is going wrong, and is it a configuration change, or is it a code break, I mean to say code failure, and things like that. They'll do a lot of post monitoring, and then they will try to fix the issue and then redeploy the application again, isn't it? So the entire process is going to take some time, even if the developers are so fast and they are doing terrifically fast. Also, it would take minimum half a day, right? Even if every environment, developer has a access to production environment also, but people can take 1/2 a day to probably 2-3 days time, right? But for a business point of view, every second is money, isn't it? When the application is running, when the users are creating transactions, imagine transaction based systems like Amazon and all. Imagine Amazon application is not coming up for one day. What's going to happen in India or across the globe, for instance? Is it not a loss for a lot of loss in terms of revenue for them? Absolutely, right? So every second is money for in the application. So application is generating revenue. So if one of the instance, or if the application goes down, then there is a huge problem. And even if we deploy our application into multiple instances to maintain replication and failover and all, since the same code is getting replicated every instance is replicated with the same code, the problem is that if one instance is going down, obviously the other instances also will go down if it is a code breakup or some new kind of function that has not captured, and then eventually it is generating exceptions.
No,
Yeah.
the call's live.
Just a second, guys.
Yes, I will be working 24/7. Saturday only, but I'm on my own business, right? For me, Monday to Saturday, the office. So
I'm sorry, guys. I just forgot to know your background or your expectations. We'll just pause here and spend few minutes to just understand your expectations. I thought most of you are here for microservices and all. I just want to understand from you. Can you just introduce yourself for for 10 seconds or 15 seconds and quickly let me know the expectations that you have? Guys, you can introduce yourself and then just let me know the expectation, and then just give us the background that you have. I mean, what are you working on? What are your expectations and all? Let's start with Rajni. Guys, are you able to hear me?
Yes.
Yeah. Can you volunteer yourself, guys, to introduce? Ramakrishna.
Okay. So basically, I'm from BPM background, so just trying to understand the architecture of microservices, Kubernetes, and it was also mentioned Spring Boot as well, right? So I joined webinar to understand the architecture and how things happen in microservice and stuff like that. So
Okay.
that's the main motto. Thank you.
Yeah, thanks. Rajni, if you are there. Hello. Okay, since he's not responding, we can continue. Yeah. So the idea is that if you are looking for Spring Boot as well, we can cover that part
Hello,
as well as part of this. Yeah. Yeah.
if you were calling my name. Yeah, I would like to learn Java and Spring Boot, which I'm already working in, but would
Okay.
like to know. So I am interested in microservices, so attending this seminar.
Wonderful. You have already you are already aware of Spring Boot and all, right?
Yeah, a little bit, yes.
Okay. Are you
Yeah,
still
not,
looking for the deeper concept of Spring Boot and then move on to microservices, or still you are okay with starting from microservices?
yeah, I can. We can go ahead with this, I believe.
Okay. You have already worked on REST-based applications, right? If you are
Yeah, a
using
little.
Spring Boot. Okay. No problem. No problem. All right. Thank you. Yeah, we can also cover, guys. We can spend a few days to understand, Spring Boot and all. Essentially, the Spring Boot concept is that, making the development easy just by creating different modules. So Spring Boot already gave us flexibility to create project, essentially with different frameworks. I mean, though Spring Boot itself is a framework, it came up with different libraries. Let's say each for interacting with the database, for transaction management, and also, in fact, even in microservices, we will use a lot of Spring related. What do you say? Let me take you through that one once. Let's say if you type spring.io, you can just see here, the umbrella of having, different projects. You just go to the Spring Cloud, Spring Data, Spring Injection, Batch Security, etc., etc. Let's take the case of Spring, right? Spring Boot, and see, different basic modules that are coming under here. Just look at here, guys. Under data, you will be having, again, different projects. We call it as Spring umbrella. Under Spring, you will be having different libraries. Library support for JDBC connection, library support for persistence API. We call Java persistence API, LDAP, MongoDB support, Redis. As soon as new databases are coming up, they are trying to provide and create libraries for us. All that we have to do is we can consume them directly as service. There is support for Cassandra. I mean, I'm talking about the different data related things under Spring. So mostly it is database related. That's why you are able to see here the data related libraries. And if we are looking at let's say security, let's take the case, it would be covering the auth related thing, SAML and Cobra OS, right? Let's take the case of session management. You will have different session management aspects for different databases, and also you can take graph query language, and for high speed high intense space. I mean, when I say high intense, it is TPS, transactions per second. If you are looking at higher transactions on big data systems, you can go for that. And messaging support, like okay, messaging support for the RabbitMQ, ActiveMQ, things like that. And also you can see, plethora of support is there, guys, here for Spring. And in fact, if we are looking at microservices, we will be using Spring Cloud, for instance. For a lot of our applications, we use Spring Cloud for different microservices as well. Alibaba is one of the web services hosted like AWS and Azure, and we have a mechanism to configure API gateway as well. Okay, we will use Spring Cloud Gateway for us to act as a API gateway. Google Cloud support is there, Kubernetes support is there, etc., etc. There are a lot of Spring Cloud open fail for circuit breaker, for example. Okay, plenty of support is there, guys. So learning Spring is the good thing, and probably whatever are the necessary components that we have, we can touch upon the requested services or required services, whatever that we have. Okay, there is a mechanism to maintain state machines, right, and things like that, guys. Okay, a lot of support is there, and provision to make integrations with third-party systems also available from Spring. So if you are interested in Spring, we can start with Spring, what is Spring, and then couple of projects on Spring with respect to using database in the application, and also performing the CRUD operations on these applications, and also things like that we can see from the Spring Boot. Then we can move on to REST-based applications using Spring Boot. For example, the web services, if you are considering in any terminology, we can say from the Java point of view, you can see REST-based applications. And prior to that, we were having SOAP-based applications. Right now, most of the applications are REST-based, and we can also cover the RESTful web services before we jumping onto microservices. We can still cover those points if the expectation is so. I hope I'm clear on that point. Just give a quick confirmation, guys. Are you able to understand what is Spring Boot and how we are going to create applications using Spring Boot? Simple or sample applications, medium level applications, I mean to say, with respect to covering the aspects of Spring, AOP, IOC, and also the MVC, probably with the data source. With confirmation, guys, yes or no, so that I can move forward.
Okay.
Yeah, and then we will jump into monolithic application like this, right? This is essentially the same thing we can create using Spring Boot, right? We can create presentation layer probably with a couple of HTML and JavaScript, or even React, whichever we like, couple of pages, and then we can underline, we can create business layer and service layers to interact with the database, and then we can essentially create monolithic application, right? And we have stopped exactly at the same juncture, right? The disadvantage of having monolithic application. Yeah, so if one of the instance goes down, if it is a configuration based change, then probably other instances may not be giving trouble to us. But if it is a functionality failure or new function that new scenario that production is able to produce, then it's going all the instances are going to fail. So essentially there is a service breakdown happens from the monolithic service, and the source code is also tightly coupled, and we cannot inject new features, right? Let's say if we would like to to generate a new functionality, then a lot of code changes happens to the existing functionalities as well with the approach of tight coupling, right? So we generally try to prefer loose coupling, and we would like to have a service created holding. I'm sorry, holding single responsibility, right? We don't want microservice to hold multiple responsibilities. The reason is that any new functionality or new feature has come up, so we can, if the feature is mostly independent, then we can create a microservice for that feature or for that entire module itself. That's the advantage, so that it can interact with other microservices for a data exchange or whatever the interaction that it is supposed to make through the application. Okay, that brings us to move to the next session. How we can convert the monolithic application into a microservice based application, right? Same service case, just look at here. So product service, user service, and order service, right? We have bunch of users, right, with their profile maintaining and their transaction that has been made by the user, and all. We have list of products to sell, and users can search and then create purchase orders. So three different services. Of course, we have plenty of other services as well, but for case of, for this instance, I'd like to explain you with three services which are mostly known to the people. So how are we going to change the architecture from monolithic application to the microservice based applications? That's the essential point. How we are going to change. Just look at here, guys. For all the three services, we have created one. Is my pointer visible? Yeah. All the presentation layer has brought to one microservice. Here, mostly we are maintaining presentation. Probably why we have separated, the reason is that responsiveness of the application has to be faster in front end. If we click on something, it should not give us buffering symbol, right? If the buffering symbol is coming and process is going to take long time, then our application is going to end up giving bad response, or what is a bad service to the customer. So that's why we just separated the presentation layer, and all the presentations that are required, presentations in the sense different UI screens that are required, are maintained here, and all the configurations that are related to the presentation layer or GUI are maintained in one database. So that different databases we are using for let's say one database for microservice, so that the database also not getting heavy. Okay, what is the disadvantage if we put all the tables under single database and try to perform the transaction? It's going to take a lot of time, right? The latency is going to be very huge, and you will expect very less TPS support, right? Transaction support is going to be very, very less. Okay, that's why we generally separate database. In case if you are fearing that multiple databases are coming, essentially we are using the same instance, but this product service, the database which product service using, will not be used by the user service. If the data exchange is required, then user will request product service to fetch the information and then give, instead of user directly consuming to database. Okay, that way it is clearly separated. Okay, second thing is, look at the responsibility. Each service is created separately. Let's say product service is a separate microservice. User service is separate microservice. Order service is separate microservice. And all of them can commonly use GUI, where user can give input to GUI, and the GUI will call the respective microservice based on the call that user has made. Okay, and if you look at here, if you look at here, Let me take the client application running, and client application is running on port number 88, right? And client application wants to consume the services, right? Let's say if you look at here, product service is running on port 51217, and user service is running on 65,130 port, and auto service is running on 49,446, or we can say essentially, 80, 81, 80, 82, 80, 83 also doesn't matter, right? So, but the port for each microservice has to be different, right? Each application is running on different port. That's our aim. Second thing is how a third-party application or user can interact with our microservice-based applications. And before that, I would like to explain three more aspects here. You can see the first one is centralized configuration. The second aspect is discovery service. We call it as Eureka Discovery Service because we are using Eureka library, and also API gateway along with load balancer. Okay, these are the different terminologies that we will use. At the end of this slide, I would like you to know all these three terminologies so that things will be clear. First of all, when client application is interacting with our microservices, let's say they might be firing so many number of requests. First point I will make that when microservices are getting created, each responsible entity is getting created as a microservice, let's say product service, user service, and auto service. How they are going to be communicating with one another? How they are going to be communicating with one another is the first question. Okay, because we are creating probably hundreds of microservices in a large enterprise applications. How they are going to communicate with each other? How does product service know there is a service called user service existing? Or how does user service know, there is a service called product service existing? Or how both of them and both of these microservices know that there is other service called auto service existing? Or how does they know? The first thing is each and every microservice that we are going to create are going to be registered and maintained under one server called naming server. People do call them as discovery server as well. That means every microservice that we create is going to be registered with the server. Why it has to register? Simply being to notify everyone that there is a microservice called product service which is running on port number 51217, and they can exchange the information by calling that service. Okay, that's the advantage, or that's the reason that we register our microservice with naming server or service, a discovery server. Okay, so each and every microservice that we are creating is going to be registered with the discovery service. So that discovery server is responsible for organizing the request and response between the microservices. When they communicate to each other, this guy is responsible, called discovery server is responsible to ensure that one service know the other service by port. Okay, so user service can interact with product service with the help of discovery server, right? Okay, so and discovery server is a server just like master and client, server client architecture which follows. All the microservices are clients registered to the server. Okay, in our case, Eureka is going to be the naming server or discovery server for us, and each and every microservice that we are creating here would be registering with discovery server so that they can communicate, exchange the information. Okay, point number one. Point number two, okay, fine. And is it safe to expose the microservice which is running here to the outside people? Let's say by chance, if somebody comes to know that there is a microservice running on this product, I mean product service is called microservice, and it is running on port number 51217, and if they come to know about the domain or IP address of this service, then anybody can access this microservice from outside, right? Which is a danger. Second point, by chance, if this instance called product service is down, right? if we are creating 2 to 3 instances, one of the instance goes down, and then user is trying to hit the same product service with the same IP, which is already done, then user will get fault response, or user will get bad response, right, or exception or error response, which is not a quite good case. So for that, what do? Is we abstract microservices from the user. We abstract them. User will have no idea where the microservice is running and what port it is running. If we can abstract, we can, mask that information, that user will not know on what port the service is running and which IP the service is running. Essentially, we are making sure that the microservices are secure from the outside world. But here the question is, how does user can interact if the user does not know where the microservice is running and on what port and what IP? If it is running, then how does he interact? For that purpose, we brought another concept called API gateway. API gateway is the interface or stub between the microservices which are running and the outside world. So API gateway knows about each and every microservices, just like Eureka, because each and every microservice will be exposing to API gateway with their IP address and with its IP address and port, so that API gateway knows. And API gateway is also an application which is running on some certain IP and port. So outside world or client application will know what is the API gateway IP address, and when they fire the request to the API gateway internally routes that query to the respective microservice, because API gateway have the knowledge of has the knowledge of each and every microservice, and API gateway maintains load balancing activity. Let's say if 3 of the instances of product service running, if one of the instances is going down, then API gateway will not route the queries to or route the request to that fallen instance. Rather, it would route the request to the other available instances. Okay, you can see here I have given 3 instances of GUI layer, right? First one is running on port 9001, and the second instance is running on port number 9002, and the third instance is running on port number 9000. Any questions here, guys? Any questions here on discovery server? Yeah.
Yes. So the microservice, let's say the product service, right, which is able to access the database and provides the API response to any other microservice, right?
Yeah.
Okay. So then the product service, which is not an API, which is not going to retrieve the database, but in case if it is going to make a call to the external API or like vendor, so in that case, is it going to be registered only in the API gateway, or is it going to be registered under the Eureka as well?
A wonderful question. Let's say your question, if I have to essentially put it, how your microservices are going to interact with the external systems. Am I correct?
Yeah, I understand that the abstraction is going to happen as API gateway is going to take care of it. But in that scenario, are we going to register in the Eureka discovery service as well? Or is it going to be just under the API gateway layer?
Yeah. So each and every microservice that is present that we want to have information exchange between the microservice will register with Eureka server. Point number 1. Let's say if this service has a dependency on external system, for example, okay, so in such case we can make use of API gateway to call. Do you understand my point?
Yes, I do.
Yeah. Okay, so API gateway is the stub interface between the external entities or external systems to the microservices. Whether it is, it's a bidirectional communication if it makes, but 99% of the time it is, from external system interacting with the microservices, not microservices interacting with the external systems. But vice versa is also possible. It's a bidirectional, support. Wonderful question. Any yeah. So let's say in our example, just for understanding purpose, we have created 3 services. Let's say in enterprise application, which is a larger scale application, probably will have hundreds of microservices. Then one difficulty is that, let's say if we would like to change the configurations of each and every microservice or one microservice, for example, then does the developer has to go through that microservice and do the configuration change and build the application again and redeploy it? Or do we have a mechanism to maintain a centralized configuration so that in one place all the configuration can be configured and respective microservices can read those configuration changes, right? We have the option, latter option is available. When I say latter option, we have a configuration server available, which I have shown you. It is also a Spring umbrella project, right? And under Spring umbrella, we have the configuration server project as well, right? And what it does is all the what do you say, configurations can kept under single place to any of the microservice that you would like to make configuration changes, and those configuration changes can be applicable whichever is the necessary service which is reading that configuration can be changed. So one place configuration change instead of multiple places for each microservice, right? We can make centralized configurations and then we can distribute those configurations to the respective microservices. So here, the first point is, we are maintaining a discovery server or a naming server to make interactions between the microservices, to know each and every microservices with others. And the second thing is to protect these microservices from the external entities or external systems. We are creating an API gateway layer, right, with the load balancing, of course, with maintaining multiple instances and all, and load balancing automatically taken care by the API gateway itself. The third thing is that we can maintain centralized configuration so that the configuration changes can happen at only single place instead of at multiple places. And of course, we can maintain individual database per service. Is this thing clear? Confirm, guys. Is this thing clear? So that I can move forward. Ramakrishna, I hope you are following the architecture that I'm talking about. And you see, each and every microservice can be deployed over a Tomcat automatically.
Yep.
Right? Yeah.
Yep.
The next thing is, let's cover quickly what are the features of microservices that we are going to cover as part of this training. Right? The first thing is that some of the things that I have already covered here: service discovery, API gateway, centralized configuration. Apart from it, as I told, there is a circuit breaker concept for addressing the fault responses, or when the service is down, instead of sending exception messages, can we send default response? Okay, can we send default response? Circuit breaker concept is there, and then let's say we can create access token mechanism in transaction-based systems. We can also perform distributed tracing. Let's say multiple requests and response are getting exchanged between the microservices. Can we track them? Can we see how they are, how many number of requests are getting fired and how many successful response are coming? And those things we can still do through the concept called distributed tracing. Okay, we use Zipkin server here to perform the distributed tracing, right? And in event-based microservices, we can perform event sources, how many number of events are getting generated in a life cycle, and how we can track them and things like that. We can also perform CQRS just to separate the concept of command and query, so that the reads are getting separated from the writes in the application. Most of the times, we write very few, but we read multiple times, right? If we perform both of them together, the disadvantage is that the performance is going to be very, very low. So that's why in event-based systems, especially when multiple events are getting generated per second, if we separate the reading of the events from the writing of the events, we call it as CQRS, command query responsibility segregation. And we also have Saga, where we can choreograph, we can perform the action of choreography. We only choreograph the microservices instead of the other naming servers and all. And there is other pattern in Saga called orchestration based. Okay, these are the different features that are available, guys. And we can also see we can maintain data per database, database per service or table per service, depends on our need. Okay, these are the different features that we have in microservices architecture, and we can make use of the necessary things. It depends on the request response as well as event based. All the features I have pasted here, but we can choose based on our domain and the need. Any questions here, guys?
No.
All right. The next part is that, okay, fine. In the request response base, we will be covering all these things, and the data exchange is happening over mostly JSON. And if we would like to have it over XML, that is also fine, right? Very few applications will exchange information in the form of XML, but most of the times it's going to be JSON. Okay, still fine. We know naming server, discovery server, we talked about it. And every microservice is REST based microservice mostly. API gateway, Spring Cloud is providing. Centralized configuration, Spring Cloud is providing. And naming server, which is Eureka, Spring is providing, right? And I've also talked about fault tolerance. And in the previous thing, if you look at here, the circuit breaker, because each and every microservices are related, right? And if one of the microservice is down and the dependent microservice tries to call this service which is down, then instead of getting error response or exception response, we can simply provide default response, right? Just to make the circuit go. Okay, that we call it as circuit breaker. And as I told, we can monitor the distributed tracing, how many number of requests are getting exchanged and what are the response that they are getting. And we can also monitor our microservices, right? And we can also provide security to our microservice using a web token, JWT token, or Spring Auth, all those things, right? Depends on our choice. We will see Spring Auth mostly, JWT also. One service we will see. Okay, and in event-driven microservice, guys, we would like to cover the design patterns that are existing in event-driven microservices. So the first one is going to be database per service, as I was explaining in the diagram. Sometimes if we feel that number of databases are more and we don't want to create multiple databases, we can still go ahead with data table per microservice. We can create one table or multiple tables, and then we can use them. And we can also use event sourcing. We can capture each and every event getting generated through the microservices. Okay, that part we call it as event sourcing as part of the transaction systems. And not only that, if we would like to make the writes and reads separated, because if they perform together, then there is going to be a latency in our TPS, and then we are going to hit our TPS badly. Then we can separate the command and query. Command is essentially write, query is essentially a read. Reads and writes can be separated using CQRS, and we can perform both of them together as well. We can blend event sourcing with CQRS together. That design pattern also we can create. The design patterns I'm talking about here, we are going to create application, we are going to test these things, guys. And as I told Saga, we have choreography as well as orchestration. With respect to the frameworks and tools, we use a lot of tools, and the frameworks mostly, for orchestration purpose, we use Axon framework, which is the industry standard one, and most of the organizations are using. And I would like to cover multiple message brokers, Kafka, ActiveMQ, RabbitMQ, and the Axon itself provides message broker concept as well. We would like to cover that as well as part of event-driven microservices. Okay, a lot of coding is going to happen on event-driven microservices. Believe me, if you learn event-driven microservices, the value that you are going to gain in the industry is going to be huge, right? And managers or architects of very high experience are struggling nowadays in understanding these concepts. Okay, if you are able to understand and learn these things at the very early age, then your pay is going to be huge, and the service that you are going to provide to the organization is immensely high. The next thing is that we are going to cover how to build Docker images for our microservices. And anytime that we would like to do all the time single click, right? Single click activity. We don't want to sit there and do multiple times, or do it for every microservice, right? Instead of that, in single command or single script, everything has to happen, right? Creation of the Docker images, deployment of the Docker images, and obviously when you deploy Docker images, the containers will be coming up and we can access the containers. And we also use, for data purpose, we use Docker volumes, that also we will cover. And Docker Compose, as I told, single click all the services up and single click all the services down. We don't want to go to each and every service, make it up or make it down. Instead of that, if we have 1,000 microservices, it is difficult for us to go to each microservice and then make them up and down, right? For that purpose, what do we use is Docker Compose. And for Docker, for container orchestration, we call the concept called container orchestration. Why it is when there are thousands of applications running, somebody has to orchestrate, right? Somebody has to be there and orchestrate or coordinate between the microservice as a master, right? So Docker do provide Docker Swamp as the container orchestration tool, but we don't prefer to do it. We would like to prefer to do it using Kubernetes. We would like to do it using Kubernetes. However, how we are going to do it? Here we are not going to cover the DevOps aspect of Kubernetes or Docker. Docker is mostly covered in both the terminologies. Kubernetes, there are two views here, the developer view and the DevOps view. When we look at the DevOps view, they're mostly worried about creating pods and maintaining the network aspects, right? Networking aspect of Kubernetes, how we can create multiple pods automatically through replica set and things like that. But here we worry about only the developer aspect. How many number of microservices and how can we maintain a number of desired instances of same microservice, and how we can maintain the load balancing automatically, how we are going to make our TPS more, and things like that. We are worried here. Okay, those things would be addressed. And the same microservice, if you want to deploy on a Kubernetes service, we have 3 applications, right? You remember product service, user service, and order service. So I'm trying to deploy like this in a Kubernetes environment. We as a developer, we have a master node in our Kubernetes environment. All of them are worker nodes. In one worker node, we have three, services getting deployed, right? Front-end services, back-end, and then database. And worker node 2 contains same 3 replicas, and worker node 3 contains same replicas. Let's say by chance, if one of the instance went down, right, front end of worker node 2 went down, and 2 more services are still running, and then Kubernetes is able to bring those things. What are we targeting from the Kubernetes aspect? What are we targeting, or what are our objectives that we are going to target in this course as part of Kubernetes? Is first thing is, the deployment. The deployment should happen on single click. Second thing, the deployment should automatically take care of scaling. We call it as auto scaling. Let's say for e-commerce sites like Amazon, the load is going to be generally low between Monday to Friday, and suddenly load will increase on Friday night because most of the employees are going to fire a lot of requests, and then on Saturdays and Sundays generally the load is going to be huge. Then I don't want to call my developer or DevOps or DevOps engineer on Saturday morning or Friday night to increase the number of instances. Is there any possibility that application can take care of itself automatically by observing the load, observing the number of requests? That feature is called auto scaling, right? We will be going to do it through Kubernetes. And then all the network related aspects like service discovery and all those things, can it be taken care automatically? Yes, it does. And can we bring the insights, or the what we call it as dashboards, so that we can observe the health and also the other aspects like number of requests and response, how many number of failures are happening over a period of time, can we do something about it? Those kind of monitoring also is possible through Kubernetes. Okay, these are the things that we are going to cover as part of container orchestration mechanism using Kubernetes. Same features can be covered. Same features can be covered using Docker Swarm, guys. But generally, people does use Kubernetes a lot. Any questions here? Any questions
No.
here, guys?
No, from my end.
Yeah. Anybody else is having question? Yeah. So I'll take questions, guys. So this is what we are going to cover as part of this course, right from Spring Boot, if you would like, to creating REST-based applications, and then move on to creating request response based microservices, and then event based microservices. Then we will also cover creating Docker images and then deploying them over Kubernetes, and all those things would be covered from our end, guys, as part of this course. If you have any questions, I would like to spend some time in taking your questions, guys. Any questions are there? Have you understood, guys, the perspective of the course? Just let me know.
Yeah.
There is always a scope for us to slightly modify the content of the course, guys. Simply being, let's say, if some of the aspects are not clear, then we can add, and then we can take few days to get going. Then we will jump onto microservices. There is always a flexibility from our end. You can quickly ask your questions, guys. I hope you understood the entire perspective and how we are going to deal with these things and all. I believe. Right, friends? If we have no further questions, anybody? Yeah, somebody's asking question.
Yeah. So apart from this, actually, do you teach Java and Spring Boot as well?
Yeah, we do.
May I know your name?
I'm Anand.
Say it again.
Anand.
Anand. Okay.
Yeah.
So will you be the one who is teaching Java and Spring Boot as well, or is it
Yeah.
somebody from the
No.
this?
Yeah, mostly me. Yeah. If the time slots are not adjusting, then it would be someone else as well.
Okay.
And just a brief introduction about me. I'm having 13 plus years of experience, and I've been doing and building enterprise applications for various organizations. I'm working as the architect at the moment, solution architect, and I have experience of building event-based microservice-based applications, probably for 3-4 e-commerce organizations and a couple of banking.
Okay.
Yeah. Any other question?
So in order to contact you, how do we?
There will be, from Harsha Academy, we have, coordinators here. And Sarita, if you can give the your number, WhatsApp number here. Sarita, are you there? I'll just paste her number here, guys, so that you can contact her. Just give me a second so that it will be easy for you to contact. I'm just noting down here in the messages section. It is 9885 312299. Yeah. Let me know if you are able to see the message. 9885 312299. Her name is Sarita. Right. You can contact her, and she will be addressing all your questions.
I can't see the chat. Give me a moment.
Yeah, note down. I'll spell it out once again for you.
Sure.
988.
Okay.
531.
Okay.
2299. I repeat once again. 988 531 2299. And her name is Sarita.
Thank you.
Right? Yeah. Yeah. Any other questions, guys, from your end, respect to the course, or any other doubts if you have, you can please ask. Okay. All right, then if there are no further questions, we can wind up the session for today. And once again, I thank you all for joining this session. I hope we made the things clear for you. What are we going to cover as part of this training? And always there is a scope for adjusting the syllabus as per the requirement. that the participant have. Right? Thank you guys. Thank you for your time.
Thank you, Anand. Thank you for a very informative session. Thanks a lot.
Thank you.